Let's discuss real numbers. Informally, a real number is a number with a decimal representation. And we represent the set of real numbers by a capital R. Now, there are different subsets of real numbers. The first subset to consider are what we call the natural numbers. And these are just the counting numbers that we're used to. 1, 2, 3, 4, and so on. And we represent the set of natural numbers by a capital N. That is, N is equal to 1, 2, 3, 4, and so on. The second subset to consider is what we call the integers. The integers are all these natural numbers together with their negatives and 0. And we represent the set of integers by a capital Z. So Z is all the negative natural numbers. Together with 0. And then all these natural numbers. The third subset to consider are what we call the rational numbers, and we represent the set of rational numbers by a capital Q. And these are fractions or ratios of integers. So A over B, where B is not 0, and A and B are integers. Now, the decimal representation of a rational number either terminates or repeats. For example, 1 divided by 2. This is a rational number, and its decimal representation is 0.5, and it stops or terminates. Whereas 1 divided by 3, which is also a rational number, has its decimal representation repeating. It doesn't stop, it repeats. Now, if a real number is not rational, then it's what we call an irrational number. And the set of irrational numbers we represent by a capital I. So these are real numbers that are not rational. So a real number is either rational or irrational. So let's write that up here. Capital R is the rational numbers together with the irrational numbers. And we have that the natural numbers are contained in the integers, contained in the rationals, are contained in the reals. Let's look at an example. Let S be this set, and we want to list the subsets of S consisting of the natural numbers, the integers, the rationals, and the irrationals. Remember that the natural numbers are the counting numbers, 1, 2, 3, 4, and so on. So looking at S, we see we have 3 here, as well as 10. So these will be our natural numbers. Now, the integers are these natural numbers together with 0, and we do have 0 in our list. So let's add 0 here, as well as any negative natural number. Looking at S, we see we have this negative 1 here in the front, but also we have this minus square root 4. Because of the square root, we might have missed this. But isn't the square root of 4 just 2? So this is really just -2, which is an integer. So we'll add these to our list as well. -1 and negative square root of 4. Now what about the rationals? All of these integers are rational numbers. Because think of 3, for example. We can write 3 as 3 divided by 1, so we can think of it as a fraction. So we'll have all of these integers, 3, 10, 0, -1, negative square root 4. But what else? Looking at s, we have this 3/4 here. That will be a rational number. But also look at this last number here. Again, because of this square root, it might be misleading. But really, this is the same as square root 81 divided by the square root of 4, which is equal to 9 divided by 2. So it is a rational number. So we'll add those two values to our list here. 3/4 and square root 81 over 4. All right, finally, the irrational numbers are any number in S that are not in this set here. Namely, negative square root 5, pi, and square root 7. So our irrationals are negative square root 5, pi, and square root 7. And this is how we classify real numbers into these subsets. Thank you, and we'll see you next time.